Chapter 3, Section 2 is multiplying polynomials. So first we're going to multiply monomials with a polynomial. Right, so find the product of each for part A. What we're going to do is take 4y squared and multiply it by each term inside the parentheses. So first by y squared, and then by 3. And when we multiply, this is what we get. Since y to the fourth and y squared are not like terms, we can't combine them. That would be our final answer. We're going to do the same thing in part B. First we're going to distribute the FG to each term in the parentheses. So first we're going to multiply it by the f to the fourth. Then we're going to multiply it by the 2f cubed g. And so on. Okay, when we multiply and simplify, this is what we get. We have no like terms, so this would be our final answer. Okay, here are two more examples. So what I'd like you to do is pause the video, complete the two examples, and then hit play again to check your answers. So go ahead and pause now. Okay, and hopefully we got both of those okay. Next we're going to multiply any two polynomials using the distributive property. Little note down here, keep in mind that if one polynomial has m terms and the other has n, then the product has m times n terms before it's simplified. So for example, if we have two terms here and three terms here, after we multiply everything together, we should get 6 terms. Okay, and of course that's before we simplify and combine our like terms. Okay, so here we go with our binomial times our trinomial. Okay, we're going to multiply these horizontally. You can multiply them vertically, but we're not going to look at that in this section. Okay, so first thing we want to do is write the polynomials in standard form. Next, we're going to distribute the a term, and then distribute the negative 3. So we multiply a times a squared, a times negative 5a, a times positive 2, and then the same thing with the negative 3. Negative 3 times a squared, negative 3 times negative 5a, negative 3 times positive 2. Okay, and then let's check and count. We have 1, 2, 3, 4, 5, 6 terms, which we know we should have before we simplify. So let's simplify and combine our like terms, and this should be our final answer. Here we're going to multiply two trinomials. And we're going to do this by using a table to organize our products. Okay, you do not have to use a table. This is just a method to help you organize if you would like. So we have our first polynomial along the first column here, and our second one along the top. And then what we do is multiply each term and put them in their corresponding boxes. So this is y squared times y squared. This is this y squared times negative 7y, and then y squared times 5 is here. Alright, then we have negative y times y squared here. This is our second column. And then we have the negative 3 distributed here in this last column. Alright, so our next step is just to combine our like terms. So we have y to the 4th, which doesn't have any like terms. And then we add together all of our cubic terms, all of our quadratic terms, all of our linear terms, and then the 15, the constant, doesn't have any like terms, so that stays at the end. This would be our final answer. Alright, next, find the product. We're just going to multiply this horizontally like we did the first one. Okay, so we're going to write the polynomial in standard form. So highest exponent to lowest exponent. And distribute the 3b. And then distribute the minus 2c. Okay, and when we multiply these terms, this is what we get. And then we have some like terms in here. Let's see, b squared c is here. And we have a bc squared here as well. So there's our final answer. Okay, let's practice another one using the box method to organize our products. Okay, so we're going to write the first one along the bottom and the second one along the top. Okay, so here's the first column, second column, and the third column. Once we have all of our terms multiplied, we're going to add our like terms, which you can see are color coordinated again here. So we group together our like terms, and this is our final answer. As I said before, you don't have to use the table to organize your work. You could distribute your x squared, your negative 4x, and your 1, similar to our other examples. This is just a way to help you organize. Okay, let's take a look at a word problem. We have the number of units produced, modeled by this equation. The average cost per unit can be modeled by this equation here. We're going to write a polynomial, t of x, that can be used to model the total cost. So that's where we're getting t from. T is the total. Alright, the total cost is the product of the number of units and the cost per unit. Okay, so what we want to do is multiply the two polynomials. Okay, and here we're multiplying them vertically. You can multiply them horizontally and get the same answer. Okay, so there's the multiply by the 3, multiplying by the negative 0.1. Last, we're going to multiply by the red term, add up our like terms, and this would be Mr. Silva's total manufacturing costs. Okay, next we're going to look at some special products, expanding the power of a binomial. So we have a plus 2b to the third power. Remember that when you are using exponents, the third power means we're going to multiply this times itself 3 times. Okay, Okay, we can't distribute this 3 in here because of the plus sign. That is not one of our algebraic rules. Okay, so cubed means rewrite it out 3 times and multiply 2 at a time. Okay, so if we multiplied a and a, it's where we got our a squared. A times 2b, a times 2b here, and 4b squared. Okay, so we simplified the middle here, so we had a squared plus 2ab plus 2ab plus 4b squared. These became 4ab. That's how we got the second parenthesis. Last, what we're going to do is distribute the a to the second set of parentheses, and then distribute the 2b. When we multiply those terms, this is what we get. Now let's go through, check out some like terms, add them together. We have a squared b, and we have ab squared. There's our final answer. Okay, the next one we're going to look at, x plus 4 to the 4th. So remember that to the 4th power means multiply by itself 4 times. What we can do is multiply the last 2 binomial factors together. So we did x squared plus 4x plus 4x plus 16, like terms in the middle. That's where we got our first product. Alright, now for the second product, we have x plus 4 times x plus 4. Well, that's what we just did. So we know that parenthesis is going to be the same. So next what we have left is distribute each term from the first parenthesis into the second parenthesis. Okay, so you should see we have 3 terms in the first, 3 terms in the second, so we should have 9 terms altogether when we multiply. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we know that we got them all. Alright, so next we need to multiply. This is what we should get. And then lastly, combine our like terms. And there's our final answer. Alright, just looking at the coefficients of the variables in the final product of a plus b to the 3rd. These coefficients are the numbers from the 3rd row of Pascal's triangle. If we looked at a plus b to the 4th, which we just did, if we look at our previous answer, the exponents are the same there. So we have a to the 4th, a cubed b, a squared b squared, ab cubed, and b to the 4th. Pascal's triangle, which we saw in class the previous day, you get from adding the 2 terms above to get to the next term. So 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6. Okay, and again we saw this yesterday in class. And each row of the triangle gives the coefficients of the corresponding binomial expansion. Alright, so the binomial expansion is in the form a plus b to the n. Okay, these following statements are true, so this would be a good screenshot to print out and have with you, and we're going to talk about this more in class tomorrow when we look at our examples. Okay, but I just wanted to make sure that you had these notes in here before class. Alright, and that is the end of our video.